Hello everyone, welcome back to my channel. So in this video we are going to learn about time domain equation. Okay, so time domain equation of WBFM signal. Okay, so I'll explain you very clearly how to derive the time domain equation of WBFM signal. If you are first time to my channel, please consider subscribing and encourage me to make more videos like this. So before learning the time domain equation of WBFM signal, first of all we have to have some basic knowledge regarding Bessel function. Okay, Bessel function, because we are representing the time domain equation of WBFM signal in terms of the Bessel function. Okay, so just the basic points which we require for the derivation only we are going see now. Okay, so Bessel function is represented by Jn of x. Okay, so where x is the argument here. Okay, so x is argument. So this formula is given by 1 by 2 pi integral minus pi to pi e power j x sine theta minus n theta d theta. Okay, so this is the formula of Bessel function. Only just remember this formula. We'll use this formula somewhere in the derivation of time domain equation for WBFM signal. So next is the properties. So properties of the Bessel function you have to learn. That is three important properties only we have to remember. So Jn of x value decreases. Jn of x value decreases as n value increases. Okay, that means if n is equal to 0, J naught of x will have as n value is increasing, Jn of value decreasing, so that means Jn naught of x will have highest value when compared to J1 of x, and then J2 of x, and so on. Okay, so as n value here increasing, Jn of value is going to decrease, that is it will have the highest value. Okay, so this is the first point which you have to remember. Second point is J minus n of x. J minus n of x is equal to minus 1 whole power n into Jn of x. Okay, so this is the second property of Bessel function. For negative coefficients, J minus n, negative Bessel coefficients, its value is equal to minus 1 whole power n into Jn of x. That is, if n is even, then J minus n of x is equal to Jn of x, because minus 1 whole power 2 or minus 1 whole power 4, everything will become 1, so this value is equal to this value. So Jn of x is equal to J minus n of x is equal to Jn of x. If n is odd, then J minus n of x is equal to minus Jn of x. So minus 1 whole power 1 is minus, so this minus 1 multiplied by Jn of x will become minus Jn of x. Okay, so when n is odd, these are the value. And third property which you have to remember is summation n is equal to minus infinity to infinity Jn square of x. Jn square of x is equal to 1. Okay, so if you take the square of the coefficient, square of this Bessel function, square of the Bessel function for all the values of n, then its value is equal to 1. Okay, mean square value is equal to 1. Right, so if you learn this Bessel function formula and these properties, so this Bessel function formula and these three properties, then we are going to use in the analysis of WBFM signal. Okay, so right now we will see the time domain equation, derivation for time domain equation. Okay, so time domain equation for WB-FM signal. Okay, so now we'll see this. So we know that the standard single tone FM signal equation, is given by AC into cos of 2 pi FCT plus beta sine 2 pi FM into T. Okay, so this I can write it as AC into, so S of T of something like we'll take it as WB FM signal, AC into, so I can write it as real part of e power j 2 pi FCT plus beta sine 2 pi FM into T. Yes or no? I can write like this because we know that real part of e power j theta is equal to cos theta. So e power j theta can be written as cos theta plus j sin theta, and real part of this is equal to cos theta. So since there is cos of this function, so I can write it as AC into real part of e power, this total I am taking it as theta. Okay, this total value I am taking as theta, so e power j theta. So this can be split into two parts, a power m plus n form, a power m into a power n. So this is e power j 2 pi FCT into e power j beta sine 2 pi FM into T. Beta sine 2 pi FM into T. So this is S of T of WB FM. Okay, let this be equation number 1. Okay, so let this be equation number 1. We'll use this equation number 1 later. Okay, just assume that it is equal to equation number 1. So now consider signal e power j beta into sine 2 pi FM into T. Okay, let this be a signal f of t. Okay, so e power j theta, this is of the form e power j theta, so it is a periodic signal. So we know that e power j omega t is a periodic signal with period. So here the frequency is FM, so it is a periodic signal with t is equal to 1 by FM. Okay, so it is a periodic signal with t is equal to 1 by FM. So representing this f of t in exponential Fourier series. In exponential Fourier series, so we have f of t is equal to summation n is equal to minus infinity to infinity Cn into e power j n omega naught t. Okay, so this is the standard form of this, where Cn represents the coefficient of exponential Fourier series. And what is omega naught? Omega naught is equal to 2 pi by t, so is equal to 2 pi by what is t? 1 by FM, so it will be becoming 2 pi FM. So this is the omega naught value. Okay, so this is f of t. Okay, so this is f of t, which is given by this signal. Now we have to calculate the Bessel coefficient, trigonometric Fourier series coefficient value. Cn is equal to, given by the formula, 1 by t integral minus t by 2 to t by 2 f of t into e power minus j n omega naught t dt. Okay, so this is the equation. So what is t here? T is equal to 1 by FM. So now Cn becomes 1 by FM. Okay, so integral of minus 1 by 2 FM. Okay, so because t is equal to 1 by FM, so minus t by 2 is minus 1 by 2 FM to 1 by 2 FM. So upper limit is 1 by 2 FM. F of t is this one, e power j beta into sine 2 pi FM into t into e power minus jn. What is omega naught? Omega naught value is 2 pi FM. So 2 pi FM into t dt. Okay, so this is what you have got. So what we can write is Cn is equal to Fm into integral minus 1 by 2Fm to 1 by 2Fm e power j. So if I take e power j common, what will get? Beta into sine 2 pi Fm into t minus n into 2 pi Fm into t dt. Okay, so this is the Cn. Okay, so let me take another slide. I'll continue from there. So we have got Cn is equal to this. In the previous slide we have got this, right? So Cn is equal to Fm in integral minus 1 by 2 Fm to 1 by 2 Fm e power j beta into sine 2 pi Fm t minus n into 2 pi Fm t into dt. So in the above expression, let 2 pi Fm into t is equal to theta, some value theta. So that what will it be? 2 pi Fm into dt is equal to d theta, right? So what will be dt? Dt is equal to d theta by 2 pi Fm. Okay, so 2 pi Fm. I am converting this total integral which is in t form to theta form. Okay, right. So when limits also changes, right? When t is equal to, so t is equal to minus 1 by 2 Fm and t is equal to minus 1 by 2 Fm, then what is theta? Theta is equal to 2 pi Fm into t. T is minus 1 by 2 Fm. So minus 1 by 2 Fm, 2 Fm gets cancelled. So you get only minus pi. When t is equal to minus 1 by 2 Fm, theta is equal to minus pi. Similarly, when t is equal to 1 by 2 Fm, theta is equal to plus pi. Okay, so what can we write here is the limits also changes. So when limit changes, then what will happen? So this is equal to, then Cn is equal to Fm integral. So what can we write here? Minus pi to pi e power j. Now see carefully, you see, so beta into this total sine 2 pi f, sine of 2 pi fmt. 2 pi fmt I am taking it as theta, so I can write it as sine theta minus this is n into 2 pi fmt, and 2 pi fmt is theta again, so this is again n theta. Okay, so what is dt? Dt is d theta divided by 2 pi fm. Okay, so fm gets cancelled out. Okay, so integration is with respect to theta. Fm is a constant, you can write outside. So 1 by 2 pi I am writing outside, so 1 by 2 pi integral minus pi to pi e power j beta into sine theta minus n theta d theta. This is Cn. Okay, so but from Bessel function we have the formula for Bessel function which we have discussed in the first of this video. So minus pi to pi, 1 by 2 pi minus pi to pi e power j x sine theta minus n theta d theta. Yes or no? So this is the formula for Bessel function. So when this is, if you observe here, when you compare these two equations, what we have is, what can we write is, instead of x here, in the place of x we have now beta. So Cn can be written as Jn of beta. In the place of x we can write it as beta. So Cn is equal to Jn of beta. Okay, so therefore the function e power j beta into sine 2 pi fm into t can be written as summation n is equal to minus infinity to infinity jn of beta into e power j n 2 pi fm into t. Yes or no? So what is e power j beta sine 2 pi fmt we have written? So from the first of Fourier series, n is equal to minus infinity to infinity Cn into e power j n omega naught. Omega naught is 2 pi fm, 2 pi fm into t. So that is what term which I have written. In the place of Cn I have substituted with Jn of beta, because we have obtained Cn is equal to Jn of beta. So that becomes this signal in exponential Fourier series form. Okay, so because this signal is an periodic signal, so we can represent this as like this. We can represent this signal like this, okay, in the terms of exponential Fourier series. Okay, so now we have obtained this. Okay, so e power j beta sine 2 pi fm t is equal to this one. So from equation 1 which we have taken in the previous slide, so from equation 1, what is equation 1? S of t of WBFM, we have taken it as AC into real part of e power j 2 pi fct into e power j beta sine 2 pi fm into t. Okay, so this is what we have taken it as equation number 1. So we are taking this equation 1 now and considering this. So S of t of WB FM, okay, let this be equation number 2. Substituting equation 2 in equation 1, that means in the place of this I am substituting with this value. Okay, so what you'll get, AC into real part of e power j 2 pi fct. So e power j beta sine 2 pi fmt can be replaced by this summation n is equal to minus infinity to infinity jn of beta into e power j 2 pi n fm into t. Okay, so n fm into t, right? So AC into real part of, so summation n is equal to minus infinity to infinity jn of beta into e power j. So if you take e power j 2 pi common, what you'll get is fc plus nfm into t, fc plus nfm into t. So what is the real part of this? This is the only exponential term which is present. This is not an exponential term. So only exponential term present here is e power j theta. So this is e power j theta form, and we know that real part of e power j theta is cos theta. So this total term is theta. So this total term is theta. So e power j theta is cos theta. So writing that, we will get the standard time domain equation of WBFM signal is AC into summation n is equal to minus infinity to infinity jn of beta into, so real part of this into real part of e power j 2 pi into fc plus nfm into t. So this total is theta, e power j theta form. So the e power j theta real part is cos theta. So final expression for the standard time domain expression for WBFM signal is AC into summation n is equal to minus infinity to infinity jn of beta into cos 2 pi into fc plus nfm into t. Okay, so this is the standard time domain equation of WBFM signal. Okay, so very important, this derivation. Okay, so please keep that in mind. Okay.